Hello everyone and welcome again to 2D vector practice, and this is number 3. So in the first question we have a trapezium OBCA where OB is parallel to AC. The point D lies on BA, so the ratio BD to DA is 1 to 2. We're also given OA and OB, and we're told AC is equal to 2OB. So in part A, we're asked to determine some vectors, and if we start with OC, we can see from the diagram that OC is equal to OA plus AC. We don't have AC, but we are told that AC is equal to 2OB in the question. And timesing OB by 2 gives us 6I plus 4J. Now we can work out OC as we have OA and AC, and it works out as 13I. Next, we want to work out AB, which, as you can see from the diagram, is minus OA plus OB. It's minus OA because we're going in the opposite direction. And this works out as minus 4I plus 6J. Next, we're asked to find AD, and again, as you can see from the diagram, AD is going to be 2/3 of AB. And we've just worked out AB, and 2/3 of AB is going to be equal to minus 8/3 of I plus 4J. And to finish part A, we have to find OD, which is OA plus AD, and we have both of those values, so it's relatively straightforward to work out, and it's 13/3 of I. In part B, we're asked to show that OD and C are collinear, so they lie on the same line. Well, if one vector is a scalar multiple of another vector, then we know they're parallel, and if they share a common point, we know they're on the same line. So if we write OC and OD down together, because we've already worked them out in the previous section, we can clearly see that OD is 1/3 of OC. And as they share the point O, they must be on the same line. And we know the ratio of OC to OD is 3 to 1 because OC is 3 times larger. Next, we want to prove that OBA is 90 degrees and we want to find the area of OBCA. Well, for a 90-degree angle, the lines must be perpendicular with each other, so OB has to be perpendicular to AB. And we know that the lines are perpendicular if the gradient of one times the gradient of the other is -1. So if we sketch OB, we can see the gradient of OB is 2/3, and if we sketch AB, we can see the gradient of AB is -6/4, which is -3/2. And if we multiply those two gradients together, we do indeed get -1. So we know that AB and OB are perpendicular, and therefore the angle OBA is 90 degrees. Now, to find out the area of the trapezium, which is exactly half of this rectangle, we can use this equation, which is the addition of the two parallel sides divided by 2 times by the height. So that is equal to the length of OB plus the length of AC divided by 2 times by the length of AB, which is the height. So first we're going to work out the length of OB using the method that we've used in previous videos, and that is equal to √13. And then we want to work out the length of AC, which we could work out using the same method. However, in the question it says that AC is equal to 2OB, so we could just say that AC is equal to 2√13. Next, we want to work out the length of AB, which is equal to √52. Then we can put all these numbers back into the equation for area, and we find out that the area of the trapezium is 39. And finally, we're asked to state the size of the angle ABC. Well, if you look at AB, you can see that the length of AB is going to be the square root of 4 squared plus 6 squared. And if you look at AC, you can see the length of AC is the square root of 6 squared plus 4 squared. Therefore, that means this area here is a square. And because we know each corner of a square is 90 degrees and that BC is the diagonal of the square, so it cuts the 90-degree angle in two, we know that angle ABC must be 45 degrees. So in the next question, we have a trapezium ABCD where AD and BC are parallel. We're also given information for BD, DC and AD where K is an integer. Now for part A, we have to show that K is equal to -6. Now we know AD and BC are parallel, therefore their gradients must be equal. But first we have to work out BC, which is BD plus DC, so it's equal to 6i minus 9j. Then we can work out the gradient for BC, which is minus 9 over 6, and also the gradient for AD, which is k over 4. Now these two gradients are equal, so then we can rearrange that equation for k, and if you work it out, you get -6. In part B, we want to find the length of AB. Now AB is equal to AD minus BD because we want to go along the orange line but in the opposite direction. Now we have all these values and we can substitute -6 in for K, and that's equal to -I minus 7J. Then to find the length of AB, we use the same method we used previously, and it's equal to the square root of 50. And finally, in part C, we want to calculate the angle ABD. Now to do this, we're going to need the law of cosines. So we'll first have to work out the length of AD and BD. And AD, using the same method above, is root 52, and BD, using the same method above, is root 26. So now we can put those lengths onto the diagram, and remembering that the angle B is opposite the length B and the angle A is opposite the length A, etc., we can put those values into the law of cosines and we get this. The square roots and the squares cancel out, and then we can rearrange for the cosine of theta, and if you work it out you get 0.332820. So theta is the arc cos of that number, so it's 70.56 degrees. That's it for this video. Thanks very much for watching. I hope you're benefiting from all the practice, and please smash that like button if you are, and subscribe for more videos like this, and I hope to see you on the next one.